everyone, I'm Joe and I love science. Meet my friend Ellie. We call her Brain Trust because she's smart, and I mean really smart. We're both in a really cool club called Electropower. Electro Mission Control sends us missions to solve.
Yeah, we go on missions with Electro to solve problems. Our trusty friend Electro usually lets us know what to do.
That's right. Hi to all. I'm the famous Electro. And I see on my trusty computer monitor that Electropower has a problem to solve. Great. Okay, are you ready? Here comes the problem. What is the term that we use to describe the process of separating a liquid into its chemical parts by passing an electric current through it?
Electrolysis.
You got it, Ellie. In other words, we can use electricity to break a liquid substance down into its different parts.
Electrolysis only happens in liquids?
Yes, electrolysis can only happen in liquids. Here's how it works.
Electrolyte. An electrolyte is a liquid compound that can be separated into different chemical parts by passing electricity through it. All ionic compounds are electrolytes.
Electrolyte can conduct electricity because their ions are free to move about. The ions move about even when the electrolyte is in the molten form. Cations carry a positive charge, and anions carry a negative charge. When the electrolyte is molten or dissolved in water, the ions are free to move. Metal ions are positively charged. Examples of metals that act as cation are sodium, potassium, calcium, and aluminium. Non-metals are negative charged. Examples of non-metals that work of an ion are chlorine, bromine, iodine, and oxygen. Electrolytes decompose or decay during electrolysis.
An electrode is one of the 2 points at which electricity enters or leaves a battery. The electrode attached to the negative terminal of a battery is called the negative electrode or cathode. The electrode attached to the positive terminal of a battery is the positive electrode or anode.
Now I understand. Are you going to show us how it works?
Gee, I'm so glad you are. To understand how it works, let's carry out an experiment on the electrolysis of copper chloride.
Cool. I love experiments.
First of all, we need to understand how electricity flows around a circuit. Remember, electrons are tiny negative particles. They are pushed out of the negative end of the battery and then they travel around the wire. Look.
During electrolysis, the electrons from the battery go to the cathode. Here they meet the positive ions. The ions then change into neutral atoms by taking in electrons. All the negative ions go to the anode. Here it gives away electrons, and the electrons are sucked back into the positive end of the battery. Therefore, we have a complete circuit. A bulb in the circuit will light up. Negative ions are sometimes called cations, and positive ions are sometimes called anions.
Now, let's set up an apparatus that we need to carry out electrolysis using copper chloride solution. Here's how we set it up.
Yeah, let's do it. One carbon electrode goes through the positive terminal and the other one goes to the negative terminal.
This beaker is filled with copper chloride solution.
And the bulb goes to?
Let me put the battery on.
Hey, look! The bulb is lighting up. This means that there is an electric current flowing through the circuit.
So, Electro, the carbon electrode attached to the negative terminal is the cathode, right?
Yep, absolutely correct.
Yes!
Look, something's happening to the electrode.
Yeah, you're right. There are bubbles coming out from the anode.
Hey, that means that it's giving out some kind of gas. Let's test the gas with this damp litmus paper.
Good idea.
The damp litmus paper has turned white. It's bleached.
So, that means that the gas given off at the anode is chlorine.
Yes, you are right, Ellie. Joe, see if there's anything happen at the cathode.
Hey, something has formed on the cathode. What is it, Electro?
It's copper.
How did it get there, Electro?
Well, all the negative ions, which are chlorine ions, gathered at the anode. The chlorine ions are negatively charged because they carry extra electrons. Their extra electrons are then removed at the anode. These electrons get sucked back into the battery. That's why we can see bubbles of chlorine gas on the anode. The carbon electrodes, which is the cathode, has been coated with copper. In our experiment, the copper ions are the positive ions. At the cathode, the copper ions received electrons and were changed into copper atoms. That is why the carbon electrode is coated with copper. Okay, that was easy enough to understand.
But I still don't really understand what happened to both the carbon electrodes. Can you explain it to me again, Electro?
Sure, no problem.
Half equations are used to describe what happens at the anode and the cathode. Half equations will show us what actually happens to the ions during electrolysis. Let me show you guys an example of half equations. Again, we'll use the electrolysis of copper chloride. Copper ions have 2 positive charge. This means that copper has 2 electrons less. So, when a copper ion touches the cathode, it receives 2 electrons. Then it becomes a copper atom because the ion is no longer charged. This can be shown by a half equation. Chlorine is negatively charged. An ion of chlorine has an extra 1 negative charge. Negatively charged ions will get attracted to the positively charged electrode, that is the anode. At the anode, the chlorine ion loses its extra electron and becomes an atom. However, in the atmosphere, chlorine does not exist as chlorine atom, but as chlorine molecules. So, 2 chlorine atoms join together to form chlorine gas, which can be seen at the anode. The half equation at the anode is
So, that's how electrolysis works.
How about electrolysis using different kinds of electrodes?
Very good question, Ali. The other uses of electrolysis depends on the electrodes which react. This electrode is called the active electrode. In our experiment so far, we use carbon electrodes. These are called inert electrodes. Inert electrodes do not take part in the electrolysis process. So the carbon electrode just carry electrons and form the electrolyte.
Do metal electrodes take part in electrolysis?
Some types of metal electrodes do. These are called active electrodes. Copper, for example, is an active electrode. Let's look at the electrolysis of copper sulphate solution using copper electrodes.
How do we start?
Make sure the copper electrodes are clean and shiny. Mark each electrode with plus and negative, and then weight them. Set up this apparatus using the copper with the plus mark as the anode and the negative mark as the cathode.
What should we do next?
Pull the copper electrodes out and rinse them with distilled water. Then, dry them by dipping them in propanol and letting it evaporate. When it dry, re-weight the electrodes.
Hey, look! The copper anode now weighs less than the copper cathode.
The copper anode has lost weight and the copper cathode has gained weight. What happened?
When we electrolyze the copper sulphate solution using copper electrodes, the mass of both electrodes changed. Here, this is what happened at the cathode. And this is what happened at the anode. Copper atoms from the anode lost 2 electrons and entered the solution as copper 2 ions. So, the copper anode is an active electrode. As copper atoms formed on the cathode, the copper atoms were lost from the anode. As the copper ions left the solution at the cathode, they were replaced in the solution at the anode.
I'm thirsty. Can I have a drink?
Yes, let's have some canned drinks. Here.
Hey, do you know that the canned drink that you have is an electroplated object?
What is an electroplated object?
How does it work?
Electroplating involves the coating of a metal object with a thin layer of another metal by process of electrolysis.
Electroplating is used to make objects look attractive and shiny. The object can also be protected against corrosion. Some of the metals used in electroplating are nickel, chromium, tin, silver, gold.
Look at the things around you.
Yes.
Tin foods,
Canned drinks,
the handlebar of this bicycle,
the spoon.
jewelry.
And a lot more, all electroplated objects. Let's look at an experiment to show how electrolysis helps in electroplating.
Yeah!
Take a piece of copper foil and dip it into a tray of molten wax. Let the wax set. Then carve something on the copper foil. Remove all the wax on the area to be coated.
Hey, let's write our names.
Yeah, that's a good idea. Electro, where should I put this? On the cathode or the anode?
Clip the copper foil as the cathode and the nickel foil as the anode. After some time, take out the copper foil, rinse it, and scrape off the rest of the wax.
Hey, look! The copper foil has our names on it.
It's coated with nickel.
Now, here's what actually happened during electrolysis.
At the cathode, the nickel ion, which is 2 electrons, became nickel's atom and coated the copper foil.
Remember what an electrolyte is?
Yes, an electrolyte is a compound which conducts electricity either when it is molten or in an aqueous solution.
Wait! I remember something else. An electrolyte is decomposed during electrolysis?
Electrolytes are made up of ions.
Wait! I remember yet something else. When molten or dissolved in water, the ions are free to move.
Very good. In our next experiment, we are going to look more closely at the electrolysis of a molten compound, that is, lead bromide.
Is this solid lead bromide?
Yes.
These are the carbon rods which will function as the electrodes.
Now, connect the electrodes to the bulb and battery.
The bulb is not lighting up.
Why?
Because the lead bromide is in a solid state. Lead bromide is an electrolyte, but it does not conduct electricity when it is solid. Now, heat up the lead bromide.
Yeah,
Yes,
the bulb
the bulb
is lighting up.
The heat breaks down lead bromide into its elements, which are lead ions and bromide ions. The ions are then free to move between the electrodes when they are in a molten state. This is what happens at the cathode. And this is what happened at the anode. Now I understand what happened.
Yes, me too.
Aluminum has many useful properties. It is light, it conducts heat and electricity well, it does not corrode. Aluminum is used in many things around us. Drink cans are made of aluminum. Parts of aeroplanes, foil, window frames, electricity cables, and pans are all made up of aluminum. Aluminum is extracted from its ore, bauxite. Bauxite is mainly aluminum oxide. The impurities have to be removed before aluminum is extracted.
Let me show you how we get pure aluminium from aluminum oxide using electrolysis.
An aluminum plant uses a lot of electricity. The amount is the same as the electricity used by a small town. The aluminum oxide is melted in a large container. When the aluminum oxide melts, the heat breaks down aluminum oxide into its elements, which are aluminum ions and oxygen ions.
This is the carbon anode. The lining of the container is the carbon cathode. this is what happens.
During electrolysis, the oxygen ions give away 4 electrons to form an oxygen molecule at the anode.
So that's how it works.
Thank you, Electro. It is really very helpful for us to understand how electrolysis is used in industry.
Thank you.
You are welcome. Good luck, and remember, electropower rules.
And then connect them to a cell. Then you decant into a solution. Just sit and watch to see what happens. So in one end you have the cathode, where electrons live away the cell, and the other is called the anode, where electrons come back again. Positive ion come to the pattern, causing metals to be deposited. Negative ions go to the anode, letting some gases to be discharged. So in one end you have the cathode, where electrons live away the cell, and the other is called the anode, where electrons come back again.